In the previous video, we found some shortcuts for finding the end behavior of polynomial functions based on the leading coefficient and the degree. So if the leading coefficient is positive and the degree is even, we have an up-up situation. And again, I like to put the arrows kind of outward, just knowing that it's not strictly vertical. Not necessary, but I like it. Leading coefficient is positive and the degree is odd, we have a down-up situation. And if the leading coefficient is negative, the degree is even, we have a down situation. And leading coefficient is negative, degree is odd, we have an up, down situation. There are shortcuts for remembering that, and we are not going to go into those in this video. That actually was addressed in the previous one. So let's move on. What we're going to do is figure out the end behavior of each of these, and we don't have to have them in standard form. They could be, and that makes it a little bit more helpful, but they don't have to be. So what we're going to do in each of these situations is look at this and say, okay, what is my leading coefficient and what is my degree? We're going to do that for all of them, and then we're going to say, oh, well, this is even, this is odd, this is positive, this is negative, and then we're going to do the up, down, up thing, okay? So the up, down, up thing, it sounds like a dance. So leading coefficient in this situation is, okay, well, -1/2, and I agree with you, but then there is a 1 that gets squared, which still is 1, and then a 1 here. So if I were to multiply all this out, I'd have 1 squared times 1, which is 1, times -1/2. So the leading coefficient is -1/2. Well, the highest exponent you'll ever get on your x in this situation is x squared, and x, which makes x to the third. I do recommend that you look at that and that, right? Whoa, that should be a 1. That's a tragic looking 1. There we go. So 3, the degree is 3. So we have an odd degree and a negative leading coefficient. Therefore, this is, and we can go back to our chart. Leading coefficient's negative, degree is odd, it's up, down. Back to those shortcuts though. If you had the line y equals -x, negative leading coefficient, odd degree, the line would go like this. It would be up, down. That's how I remember it. Again, that's the kind of shortcut or just way to remember it. Okay, if I multiplied all of this out, then I would have a leading coefficient of, okay, hang with me, -1 times 2 times 2. And you're like, well, what about the 3? And what about this? Okay, the 3 would get multiplied by -3, which makes it -9. That's not going to be part of the leading term. So that's all I'm looking at is where my x's are. -x squared times 2x times 2x. So that'd be 4 times -1. So that would be negative. And my highest exponent I will ever achieve is x squared times x times x. You can do the whole thing out. You're going to realize that the highest your degree ever gets is 4. We have an even degree and we have a negative leading coefficient. Even degree, negative leading coefficient, it's going to be down, down. Down, down. Okay, let's move a little bit faster. We have a leading coefficient of 5 times 1 cubed, so 5. We have a positive leading coefficient, and the highest exponent we'll ever get for our degree is 3. So odd degree, positive leading coefficient, down, up. All right, oh, this one's going to be easy. Leading coefficient, degree, here we go. Leading coefficient in this case is -4. Ah, this is not in standard form. It's close, but it's not in standard form. Everything is reversed. This is your leading term. So leading coefficient is -4, degree is +4, even degree, negative leading coefficient, down, down. Like a negative parabola. It's not going to look that way, but that's how I remember it. Okay, what's the degree? Let's start with the degree this time. The degree, oh, there's a high number. There's a slightly higher number. That's it, 828. Leading coefficient is -1. We have an even degree, a negative lead coefficient, so there we go, down, down. All right, a couple more. Leading coefficient in this case, I hope you're trying these on your own, is 1 times 1 squared times 1 cubed times 1 to the 4th. I think that's a 1, right? The degree is 1, x to the first, x to the second, x to the third, x to the 4th. 1 plus 2 plus 3 plus 4, that's 10. even degree, positive leading coefficient, up, up. All right, last one. Leading coefficient, degree. Okay, it's about to get a little tricky. So the leading coefficient in this case is negative 1/5 times 3 times 2 squared times 1 squared. And I haven't shown this work on all of these, but I am on this one, just I want you to see it. So in the process of doing all this, we have positive, positive, positive times a negative. So we're going to end up with a negative. Instead of writing negative, I'm going to put negative, so it's less than 0. So when I said leading coefficient equals, well, at this point, I really don't know what it equals. I can figure it out. It's 3 times 4, so they're 12/5, negative 12/5. But what I could have been doing all along, instead of saying, oh, it's equal to such and such, I could have said, oh, it's negative less than 0. Or if it was positive, of course, it'd be greater than 0. So, let me double check my work here because I don't want to accidentally lie to you. Yep, we're good. The degree is x to the first, x to the second, x to the second, 1 plus 2 plus 2. It's going to give me 5. Odd degree, negative lead coefficient. It's going to be positive. Sorry. It's going to be up, down, I should say. Going to be that. All right, I'm going to scroll through, make sure I didn't accidentally lie to you anywhere. And the bottom one is good. Yeah. And the next one's good. And that 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 one is good. And we can just keep scrolling backwards and making up more, but let's not. I think we got it.